Kirchhoff's circuit laws. Kirchhoff's circuit laws are two qualities that deal with the conservation of charge and energy in electrical circuits. They were first described in 1845 by Gustav Kirchhoff, widely known in electrical engineering. They are also called Kirchhoff's laws or simply Kirchhoff's laws. So what are they? What are they exactly? There are two rules. One is called the junction rule and one is called the loop rule. So what is a junction rule? The junction rule states that at any point in an electrical circuit, the sum of currents flowing towards that point should be and must be equal to the sum of currents flowing away from that point. The result of the conservation of charge gives us the junction rule. This means sigma in, the current in, minus the current out has to equal 0. The loop rule is the expression of energy conservation applied to changes in potential in a circuit. That means the algebraic sum of the electrical potential around any closed circuit must be 0. So these are the two rules. Now how are they applied to actual circuits? So in a circuit you are going to have two basic components. You are going to have resistors and you are going to have a battery. So with your resistors, if your path is with the direction of the current, the potential will drop and you will put minus IR. If your path is opposite to the direction of current, then the potential will rise and delta V will be plus IR. For your batteries in your circuit, if your path is from the positive to the negative terminal, you will put a minus E, and if your path is from the negative to the positive terminal, you will put a plus epsilon. Trust me, write these things down. These rules are very, very important to remember, and I will solve a problem that will help us figure out what we're talking about. So, here's a problem-solving strategy. Please make sure that you understand this very carefully. Take a pen and a paper and write these things down right now. Replace any series or parallel combination with their equivalent resistance circuits. Give names to the currents in the circuit. Choose directions for each current. Draw on the circuit. Remember, current changes at the junctions only. This is very important to remember. Current changes at the junctions only. Next, apply Kirchhoff's junction rule to all but one junction in the circuit. Current into the junction, call it positive. Current out of the junction, call it negative. Apply Kirchhoff's rules to enough loops such that you have, along with the junction equation, the same number of equations as the unknown. Remember, for each resistance, if your chosen path is along I, downstream, we will have potential drop. If it is opposite to I, it will be upstream and potential will be gained. Battery terminal, from positive to negative, put in a minus epsilon. From negative to positive, put in a plus epsilon. Again, make sure that you understand what we are doing because we are going to solve a problem using these strategies. So if this was a sort of situation that you were given, you were asked to find all the currents to each branch of the circuit to the circuit given below, the best way to do this would be using Kirchhoff's laws, and I will show you how to do those right now. So we are given a 2-loop circuit, okay? And that circuit looks like this. Now we have to be very, very careful in the directions that we choose. So this is going to be plus, this is going to be minus. And that, and this is going to be plus, and this is going to be minus. So in circuits, the bigger sign always means plus and the smaller sign always means minus, okay? So these are batteries and these are resistances. So it will be R1, R2, and R3. And we are given R1 is 4 ohms, R2 is 6 ohms, and R3 is 3 ohms. So the first thing we need to do, and the easiest way to do these problems, is for one of the equations that we need. So we have 3 unknowns because we have to find 3 currents, right? So the idea is we are going to need three equations. The easiest way to do this is probably to figure out that the first equation I am going to use is going to be my junction rule, right? What does the junction rule say? The junction rule says delta I equals 0. What that means is all the currents coming in and out of this circuit, out of this junction that I have chosen, have to equal 0. I'm going to start off by assuming that all my currents are going to be flowing into the system. I1, I2, I3 all flow into the system. And can I do that? The answer is probably not. But I'm going to do it knowing that one of these or two of these currents have to be going outwards. If I pick one and I am wrong about it, I will not know whether the answer is wrong or whether I am wrong. But if I pick all of them to be going in, I already know that one or two of them have to come out. So I'm okay there. This means what I'm saying is I1 plus I2 plus I3 all have to equal 0. Okay, that's one equation. And I know, as I said, one or maybe even more of these have to be coming out. But I've assumed them and I'm going to stick with this, okay? Now, there are three unknowns I need, I1, I2, and I3. So I'm going to need three equations. I already have one equation done. Now my second and third equation I can get from my loop rules, right? So what are my loops that I can choose? I can choose one loop that could be this way, one loop that could be this way, one loop that's all the way around, or any other loop that I want. But what I'm going to do is I'm going to call this left loop and right loop, just to make life a little bit easier for me, okay? So I am going to pick left loop and right loop. So for my left loop, I am going to find delta V equations. How am I going to do that? Okay, my left loop, right? What will it be? Let's say I start walking from here. So I draw my person here that is going to start walking, okay? This person walks that way. It is going to encounter batteries and it is also going to encounter resistances. So here I'm going to make a note for myself and say when my person encounters a battery, if it goes from the positive to the negative terminal of the battery, it is going to be negative. My answer has to be, my V has to be minus, okay? And I'm going to make a note here that when it goes through a resistance, if the current is in the direction, then I'm going to have a potential drop. Okay? And it will make sense in a second. All I'm doing right now is making notes for myself. So along current, I'm going to have a minus I. What does that mean? Okay, so my person starts to move this way. When this person comes to this battery, what does it see? It sees that I am going to go from the negative to the positive terminal. I immediately come back here to my notes and it says, ooh, okay, from the positive to the negative is negative. So my person is going from the negative to the positive. What should I do? Yes, plus E1. Let me call this E1 and let me call this E2. Okay, plus E1. Then this person walks here and it comes here, right? And it encounters a resistance, R1. What do I know? I know that it is going to go along my current, which means if I'm going along my current, it is going to be a potential drop. What was the chosen direction of my current? This way, right? So that means it's going this way, and that means it's going this way, right? I just chose that. If it is along, and my person is also walking along, these both are the same directions, what do I have to do? Minus I1 R1. Good? Okay, now next, my person walks along the direction, and then it goes down here, right? My chosen current direction was upwards, but my person is coming down. The next thing he sees is R2. So I'm going to put a plus I2 R2, and then my person comes back to rest. So it goes back to rest equals 0. Okay? Does that make sense? So here's what the guy did, right? So my person walked, it encountered this. I put a plus because it's going from minus to plus. Then it comes here. I put a minus because it's along the direction that I chose. And then it comes here. My person comes here. and because my loop is this way, it comes down here. I put a plus because my chosen current was upwards, my person's walking downwards, it's opposite, I put a plus, right? It gains potential. And then it comes to rest where it started. So this is where I want to start and stop, okay, for my loop. Now, let's talk about the right loop, okay? Same person, I'm going to put a box around it now. This person has to start moving upwards, right? Because my loop I chose is that way. Now in this case, if it's going upward and the current is also going upwards, I am going to have minus I2R2, right? Along this path. Then this person comes here and it goes that way, right? So my person goes this way, comes down. Now my current is chosen to be going that way and the person is walking down, so I'm going to be plus I3R3, okay? Then my person comes down here, it goes through minus to plus will be plus epsilon 0 equals 0. So watch this very, very carefully. This is very important for you guys to recognize how to set up these equations. Once you have these equations set up, life becomes a little bit more simple. So what I want you to do now is I1 plus I2 plus I3 equals 0. Then we are going to have I1 R1 minus plus I2 R2 plus 0 equals minus epsilon naught. I'm just rearranging these. This one will be 0 minus R2I2 plus R3I3 gives me minus epsilon 2. Now why did I do this? The reason why I did this is because I actually have the values for R1, R2, and R3. And I'm going to be able to replace them with it. So you do another step. What is I1? Sorry, what is R1? 4. What is R2? 6. What is R2? 6. And what is R3? 3. Okay? Now I have 3 equations. And I have 3 unknowns because I wanted to find I1, I2, I3. Right? This is what I needed to find. So you have 3 simultaneous equations, you have 3 unknowns, and you can easily find them. Given epsilon, okay, the other thing I did not give you was epsilon 1 and epsilon 2. So, given EMF 1 to be 1.5 volts, and epsilon 2 or EMF 2 to be 3 volts. You should be able to solve these. So I'm going to replace this with 1.5 and I'm going to be able to replace this with 3. Okay? You should be able to solve them. There are many ways on how to solve these simultaneous equations. My favorite one is called the Cramer's rule, but you may feel free to solve them any way possible. If you have a calculator, feel free to use that, or you could use the software available on the internet to be able to solve it. Okay. My answers for this question particularly come out to be I1 equals 0.58 amps, I2 equals 0.138 amps, and I3 equals minus 0.722 amps. Okay? Now, remember, when I started out and I said, one of them is going to be wrong, and absolutely, one of them comes out with a minus sign, this means that my chosen I3, which I chose to go inside, is wrong. It's actually, that current is actually coming out.